So we are dealing with problem 2.29 in the I.E Irodov solving series, and the problem is stating gaseous hydrogen contained initially under standard conditions in a sealed vessel of volume 5 liter was cooled by 55 Kelvin. Find how much the internal energy of the gas will change and what amount of heat will be lost by the gas. So it is a very systematic and simple problem. If we look at it, then let's get started. So the problem is stating that it is under standard condition. So under standard temperature and pressure conditions, we can say 1 mole of gas occupies 22.4 liters. So at STP, we can say that 1 mole of the gas is going to occupy 22.4 liters. Now in this situation, it is said that it is occupying 5 liters. So therefore, number of moles of hydrogen gas present. So since it is containing 5 liters, so we can say the number of mole N is going to be 5 divided by 22.4. So this is the amount of gas or the moles of gas which is contained. Now since it is a diatomic gas, so for diatomic gas CV is going to be 5R by 2. And the change in temperature which is mentioned is 55 Kelvin. Another important thing which the problem is stating is that it is in a sealed vessel of volume 5 liter. So since it is a sealed vessel, so we can say that the process is isochoric in nature. The process is isochoric in nature and work done is going to be 0 because it is a sealed vessel. So we can say that the volume is not changing. So since volume is not changing, work done is going to be 0. So if we calculate internal energy change delta U, which is given by NCV delta T, then we can say that the number of moles is equal to 5 divided by 22.4 CV, which is 5R by 2, and change in temperature which is 55 Kelvin, and since it is cooled to 55 Kelvin, we are writing over here minus 55 Kelvin. That is, the internal energy will be negative. The change in internal energy will be negative. So therefore, on solving this, we obtain delta U is minus 255 joule. Now in the next part, the problem is also asking us to calculate the amount of heat which will be lost by the gas. So we can say from first law of thermodynamics, we can say that delta Q equals delta U plus delta W, and since work done is 0, so we can say that delta Q is going to be delta U, which is going to be minus 255 joule. So both the answer is going to be 255 joule, and since the problem is asking the amount of heat lost by the gas, the negative sign is already representing the heat lost by the gas. So we can directly say that the heat lost by the gas is a positive value 255 joule, or we can write it as 0.25 kilojoule. So this is the final answer which we have for this particular problem, change in internal energy and the heat lost by the gas. So this was problem number 2.29.